All right, so we're here looking at some of the questions from the physics classroom. This is specifically EC1 for electric current 1. And the first question that I have here, it may be a little difficult for you to read, but I'll zoom in here. It says over the course of an 8-hour day, 7.18 times 10 to the fourth coulombs of charge pass through a typical computer. Presuming it's on the internal time, determine the current for such a computer. So to do this, we need the equation for current, and that equation is right here. Current is equal to charge, Q, divided by T time. The units, the SI units for this are amps, it's the SI unit of current. Coulombs is the SI unit of charge. Second is the SI unit of time. So what that would look like to do that calculation, the first thing you would need to do is remember the SI unit for time is the second. And you would notice that you're given time in hours. This is a problem. So you would want to convert your 8 hours into the number of seconds. And of course, these units would cancel. If you remember this, you would hours cancel, and all you're left with is seconds. That would get you to the point where you're ready to start doing the actual equation. And I've done this ahead of time, and I'll try to slide it here. I'm trying to make this videos a little less lengthy. So remember, our equation for this would be I equals Q over T. If we substitute in what we know the number of coulombs, and then we know the number of seconds. And then if we do that calculation, we would find that our current is equal to 2.493 amps. So the answer to this first question on here, on mine, with my numbers, would be 2.493 amps. Okay, so another question along here, and there's several of these, it asks for the amount of time that the following devices would have been used before a certain number of coulombs of charge passes through them. So here you're given coulombs, and it's wanting to know time, and on each specific question you're giving amps, which is current. So the first thing I would do there is I would recognize that ultimately I'm wanting time. So you start again with your same equation. Current equals charge divided by time. And then I would just rearrange this equation. And if you haven't noticed, these two, anytime you have an equation, these can always trade places. So if you trade those places, algebraically, this is sound. Time equals Q over I. Then we could substitute in what we know. Time is going to equal our charge, which it tells us up here, divided by our current, which has given us each individual time over here. It gives us these individual currents. And I'm doing this one. Not that it really matters to you. And then we can do the simple calculation, and we put in currents and amps. So of course our unit, the answer is going to end up being in seconds. Now the problem here is this wants hours, and we ended up in seconds. So we need to do unit conversion, and I'm going to move this over here to show you that to fix this. So we could do over 1 times, we got to put seconds on bottom. Ultimately, we want hours on top. So what would a conversion between these be? And we do know that 3,600 seconds equals 1 hour. So that's going to be our trick there. So then we're going to take that answer, and we can just divide it by 3,600. And we're going to find that it would be 4,477.6 hours would be our answer to this thing right here. And that's how we would do one of those. All right, so the final type of question on this beginning one here, essentially it asks if you have an air compressor that uses a certain number of amps and the startup time is a certain number of seconds, it's wanting to know how much charge passes a given point at that time. So once again, It's giving you two of the three. It's giving you time, and it's giving you current, and it's asking you to solve for Q. And you can do this any order you want, but if I was doing this, I would just go ahead and solve for Q before I start the equation. And you know that if you multiply both sides by T, you would find that T times I is going to equal Q. Then you could sub in the numbers that you have, sub in your numbers. It gives you 86.2 amps. That's current. And then it gives you a time of 0.611 seconds. That's going to be equal to your charge. And of course, the answer to this, when you do it, would end up being in coulombs. I'm not going to spend the time to run that calculation. I think at this point, you should be pretty comfortable with that. Thank you. Like and subscribe.